Welcome to today's webinar, Getting Started with Serverless Architectures. Our presenter today is Andrew Bard. Andrew is a solutions architect at Amazon Web Services in our Atlanta office. He has a broad background in software development with experience in areas including distributed processing workflows, e-commerce applications, and public APIs. In his role at AWS, Andrew works alongside AWS customers to help ensure their architectures are designed using AWS best practice. Today with us, we also have AJ Nair, Stefano Bilani, Brittany Doncaster, and Jeff Nunn. They are our webinar moderators and will be engaging with you and answering your questions throughout the presentation while Andrew presents. Andrew, welcome. The floor is now yours.
Thank you, Ryan, and hello, everybody. Again, my name is Andrew Baird. I'm a solutions architect down in Atlanta with AWS, and I'm really excited to talk to you all today. Thank you for taking the time out of your busy days to join our webinar here. Serverless architectures, and especially getting started, is one of my favorite topics to get talking about, just because I know if you haven't dabbled yet with AWS Lambda and what you can do with these services on top of AWS, you're going to be really excited by what you see. Once you leave this webinar and have some of the skills, hopefully, to go and build some demo architectures using the serverless patterns, I think you're going to really revolutionize the capabilities you have to stand up really quick, really operationally stable and scalable applications using serverless models. Okay, so let's jump in. What are we going to cover today? First, I'm going to jump into a little bit of a background, provide some context about why we think AWS Lambda and the serverless architecture patterns that it enables are really a natural evolution of good software design best practices. I'm going to dive in a little bit deeper on AWS Lambda specifically, the service at the center of this discussion, as well as provide a quick overview of Amazon API Gateway, the service that enables API-based access to your AWS Lambda functions. I'm going to do a live demo of building a serverless application using those services. And then I'm going to discuss some architecture patterns that other customers have begun adopting using the serverless architecture model, as well as, while you're getting started, provide some best practices and tips so that when you're adopting these services for the first time, you're aware of some things that will make that adoption easier and smoother for you. So first, let's talk about a background, how we think architecture patterns utilizing AWS Lambda are really that natural evolution of good application design. So in the past, hopefully many years ago for a lot of you, maybe you're still dealing with some application architectures that look like this. There's a monolithic architecture where you've got a bunch of different functional components of your application that are all co-located on shared infrastructure, shared servers. They're co-deployed, and it creates this really fragile and brittle environment where deployments are really risky. If any one of those code changes has a failure within it, a rollback may affect the entire system. It creates a lot of centralized and slow processes around approving deployments, and the speed of development is just really, really slow. Monolithic architecture is no fun for anybody, even when I'm screaming about them at you. So let's jump to the next natural evolution that came about. So everybody broke apart that architecture, kind of realized the act of decoupling an application into different components, having those components speak to each other over the network, was going to enable much more rapid development and deployment processes, get those features that your business stakeholders want to get out into your application, get them deployed faster, make those deployments smaller, less risky overall to the application, and allow teams to focus on more narrow components functionally of the application so that you can have front-end web developers and app designers that are really, really deep in those areas of technology. Those implementing business logic in your web services don't have to be experts on the front end or aware of all the functionality and how it's implemented elsewhere. And then databases on the back end and DBAs that can focus on the functionality that's been decoupled and located at the back end of the infrastructure. So since this pattern's kind of taken a foothold, obviously many millions of applications and teams have built following this service-oriented approach. There's been a move in the more recent past to kind of amplify its benefits and implement what's called a microservices architecture. That's where you take the same tenets that service-oriented architectures provide and further break it apart so that all of those benefits around decoupling, more dedicated functional areas and depth within a development team can be even more focused. The speed with which a deployment can occur can be not only faster, but maybe even automated because the functionality of that one component is so well known that the testing you can do against it is much more easily automatable. So the one thing to keep in mind that with this natural evolution of decoupling and more rapid development, there's a shared dependency that all of these different application and components have. And one of the reasons why the pattern has become so vast is just the number of tools that are available to help developers build following the service-oriented approach. There's tons of different languages and libraries for those languages that enable you to build web services, continuous integration, continuous delivery platforms, deployment patterns and best practices, a ton of well-documented material and products and frameworks that enable service-oriented architecture to be built really quickly. And AWS has helped a lot in this space too. We have a lot of different services and features within those services that specifically lend themselves to building in a service-oriented way. Obviously, APIs are at the heart of what we do as a business and as a platform. So enabling our customers to similarly build decoupled architectures that are service-oriented is one of the tenets that we provide too. But many of the innovations that have enabled rapid web service development and allowed developers and teams to decouple their applications into these many modular components share a dependency, and that dependency is kind of proliferated along the same timeline, and that dependency is servers, of course. So when you've got a massive decoupling happening within your environment, you likely have a proliferation of the number of servers that you have to manage, and each one of these questions listed on the slide is a question that you need to answer well for all of your servers. You get any one of these questions wrong as an application owner, you could have an issue related to price or cost, you could have an issue related to performance, security, and in a lot of these questions, there are entire industries or products or companies dedicated to answering any single one of these questions. So you as an application owner have to answer every single one of them. So if you could, we figured it'd be pretty compelling to be able to say, why bother? Let's build an application that's completely serverless from your perspective, have all of the servers be fully managed, nothing you have to provision, nothing to administer on those servers, no patching, no right sizing, no deploying in a model that includes high availability, have that included right out of the box, and allow your developer productivity to go way up. So all the coding that you have to write that's related to a server-based infrastructure model where you need to take into account, installing software, automating deployments and configuration management of that server, have all of the code that you're having to write that's not related to your actual business logic be handled by the service, so that your developers can focus just on the business logic that differentiates your application. And then have that business logic be deployed in a way and on top of a platform that enables continuous scaling automatically. So the service that's going to enable this type of model is obviously AWS Lambda. That's what we're here to talk about today. So you can think of AWS Lambda as a serverless event-driven compute service. And what I mean by event-driven is something I'll get into a little bit later if it's a phrase you're not familiar with. But you can more simply think of Lambda as a service to let you build microservices without servers. So in order to kind of explain what Lambda is in this context, I'm going to break it up into 4 different components that I like to think about Lambda in. And I'm going to jump into each of these and kind of define it so that by the end of defining these 4 components, you've got a good overall top-down view of the entire Lambda service and the value it provides and how to build for it. So first and foremost is the idea of a Lambda function. And when you hear people talk about AWS Lambda, Lambda functions are the things that they'll most often be referring to. This is the part of the service that's most differentiating to the different application architecture models you built before. So a Lambda function is the core and heart of using AWS Lambda, and it is literally a function that is code that you write. So one of the supported languages that we have today, either Java, Node, or Python, or any other language that runs inside a JVM, it is code that you write and deploy within this service. So all the business logic that you'd like that code to take that you'd like that code to execute, not necessarily a literal function like a JavaScript function or a Java method, but rather all of the code that will contain all of the business logic you'd like to have executed. Second for the Lambda function is the security posture of that code that you provide. And that's done through, if you're familiar with the concept of IAM roles in the EC2 service, it's the same concept here. Your code that you upload to AWS Lambda can be wrapped with an IAM role that defines what your code has authorization to interact with from an AWS service perspective. And that enables a really powerful decoupling mechanism from a security perspective, where the code that you write, all the business logic you write, so the example here on the screen is a pretty boring but complete Lambda function that says anytime this function is invoked, I'm going to write a very simple object out to S3, to a specific bucket and key with a body that's static and is written the same time every time. So when I wrap this function with an IAM role, if that IAM role gives my Lambda function the ability to communicate with S3, this code will have the ability to do its logic and write that object out to an S3 bucket. If the IAM role wrapped around this function doesn't have that capability to integrate with S3, then this function code will fail to integrate with S3, and what that leads to is all of the business logic and all the code that you write for AWS Lambda doesn't have to have any AWS credentials baked into the code. You don't have to manage rotating of those credentials, storing them in memory, keeping them encrypted somewhere. Simply wrapping your code with an IAM role allows you to write full business logic that is security agnostic and have all of those things be externalized in an IAM role. And the third piece of the Lambda function is just how much horsepower your function needs in order to process. So that's done through a single dial that allocates the amount of memory to your code all the way up to 1.5 gigabytes. And that same dial will affect the amount of CPU time and network bandwidth your function will receive as well. Now the thing to take away is that even though we're referring to this as a Lambda function and it doesn't literally translate to a JavaScript function or a Java method, there will be a literal method or function within the code you upload that we call a handler function. And that handler, you'll specify to the Lambda service that when your code is invoked, that is the entry point for execution. So that is the place where your code will be invoked, and from there forward, you can have your processing do whatever it needs to do. It can reach out to external libraries, it can call other Java classes, other JavaScript files, it can load native binaries, it can reach out to external web services, it can call other Lambda functions. This is truly your code. Once you've defined what that handler is and where that invocation will begin, it's fully up to you what your business logic is going to do. You've got a full runtime environment. Okay, so you've written your code, you've uploaded it, you defined where that processing begins within the handler, and how is it going to be invoked? And the way that's done is through what's called an event source. So what is an event source? An event source defines and informs AWS to say when any one of these events happens within some external context to Lambda, so for example, with an object landing in an S3 bucket, or a record being placed into a Kinesis stream, or somebody invoking your Amazon API Gateway API, whenever one of those events happens, it is AWS Lambda's responsibility to, one, not only be aware that that event occurred, but to bundle a lot of metadata about that event and pass it on through an invocation to your Lambda function. So regardless of what scale that event's happening in, if it's a production API that's receiving thousands of requests a second, or a report that's landing just once a week inside an S3 bucket, once you've configured that event source as a source for your Lambda function, that will tell us how often and when to invoke that Lambda function and the metadata event that would be passed to the function so that you can perform whatever business logic you need. So you can imagine that depending on the event source you configure, the event will look pretty different from use case to use case. So if you're using Amazon S3 as an event source for a Lambda function, the metadata you receive from S3 may include things like the object key, the size of the object that was just placed in, the IAM user or role that just created that object, where if you're using Amazon API Gateway as an event source for your API, you'll receive information like the HTTP request body, the path, a lot of other API-centric details so that the code you're writing in your AWS Lambda function has all the information it needs in order to perform that business logic within the code you've written. The third component of AWS Lambda you can think of as the service itself. So this is the service that we provide that takes the code you've written and uploaded and places it within a function processing environment, an execution environment, where that code's actually running and being invoked by those event sources when they occur. So it's our responsibility to place the number of functions in parallel as required, regardless of what scale your events are happening at. We wrap that code you've written with an API, a first-class AWS API, through the service if you need to invoke that function directly outside of the context of one of your events happening. maybe you're doing testing, or maybe you've got a process where just a manual trigger from an existing application to the AWS service is the way you'd like to interact with Lambda, we provide that API for you to do so. And finally, we also provide a couple other capabilities that you can leverage from within your code and as part of your operations to do things like logging within your code and have those logs be automatically streamed to CloudWatch logs, and a lot of monitoring capabilities on how your function's performing, when it's being invoked, the time it's taking for execution, those types of things. And finally, so you've written your function code, you've defined how it's going to be invoked through your event sources. Our service is responsible for placing it in the execution environment so that your logic can execute. The last component is the function networking environment. So this defines what does your code have connectivity to from a network perspective. And there's two broad options you have at your disposal. First is a default option where you have the ability to give your function access to the internet, and it's deployed within a VPC that the service manages rather than a VPC that's within your account. The second option is if you do need private access from a network perspective, you can deploy your Lambda functions within your own VPC. So you'll define which subnets those functions will get deployed into, and all of the network artifacts that you'd expect to behave within your AWS account and your VPC will determine the connectivity your Lambda function has. So the route tables, the security groups, any VPN connections or direct connects you have back to your data center, all of those things will still apply. Your functions will be deployed in your real VPC and have connectivity to anything else that lives within it from a private IP perspective. Okay. So after that, you might be saying, hold on, there's a lot of great ways already to build applications and not have to manage any servers. There's software as a service, there's platforms and mobile backends. There's lots of different ways with application engines to define custom applications where I'm not really managing any servers. What's the serverless model and what's really making it different with Lambda? So what's unique about Lambda? We think the first one's a really powerful differentiator, this idea that you're abstracting the server-based infrastructure at the code level. So code is something that we as developers are very familiar and capable of interacting with and owning. We have a lot of tools already built for managing source code, for iterating against source code and tracking changes to it. We're using real languages and real Java, Node, and Python that we're familiar with using. And all of those best practices that your development team has already around managing code will still apply to AWS Lambda. Second is the security model. AWS Lambda natively integrates with two of our security-centric services that have been around for years and are very mature: identity access management for those IAM roles that will wrap around your function and define its authorization level, and VPC for the network privacy that you require potentially. The next is a very important one as well. The pricing model is very unique to Lambda, where you're getting charged at very small 100 millisecond increments of your execution time for your Lambda functions. So there's no longer this concept of paying for idle compute time where you've got server-based infrastructure that has fluctuations throughout the day of how much it's being utilized, but you're still paying an hourly rate for the amount of time those servers are up and running, regardless of how utilized they are. With Lambda, where you're getting charged specifically on the number of invocations of your function and sub-second execution time, you're no longer paying for that idle execution time. You're getting billed exactly for the amount of compute time that your code required to run. And additionally to the great pricing model, there's also a very large and generous free tier where you have the ability to have your first 1 million function executions with AWS Lambda be free every month forever. So it's not like some of the other free tiers we have where that model rolls off after the first 12 months of an account, but in perpetuity, the first 1 million function executions of a Lambda function are free every month. So a lot of great use cases you might be able to implement operationally or just to get started where you won't incur any cost at all using AWS Lambda. Next is the community. So Lambda's been around for a long time already, almost 2 years already. The community's really embraced it, and there's a ton of great documentation, a lot of open source projects that leverage Lambda, a lot of great examples for you to get started with and to be able to get off and running with a community that's discovered and implemented a lot of the things you might be thinking about already. And last but obviously not least is just the idea that Lambda integrates very natively with the rest of the AWS service ecosystem. So all of the other services that we provide, the scale with which they operate at, the different capabilities functionally they can provide to an application are co-located on the same platform and integrate with the same security posture through IAM that your Lambda functions will. So if you're building an application that obviously needs more than just a compute platform, you need database storage, you might need messaging or queue-based applications, the ability to manage users. We have a slew of different services that still don't require you to manage any server-based infrastructure that your Lambda functions can integrate with. So I've given an overview so far of what Lambda is and the different pieces of it, how to understand it a little better. Let me give you an example of what one of our customers did and how they implemented a serverless architecture using AWS Lambda. So this customer, Play on Sports, who's based here in the Southeast, implemented this really cool architecture where they, as a business, give the capability to folks attending sporting events or other events in person, the ability to take a laptop encoder and stream that event in real time to folks that aren't able to attend in person. So think about, aunt and uncle, grandma, grandpa want to watch a high school football game, but they're not able to attend in person. This is a company and an application that allows that to happen through someone attending the game and streaming that live via this laptop encoder device. And the way that's implemented is here on the screen, completely serverless. So this company's got a laptop encoder that allows those attending the event to record the video and stream it through CloudFront and S3 in real time. And as those objects, those video chunks, land inside their S3 bucket, they're using that as an event source for a cascading set of Lambda functions. So as soon as that video chunk hits S3, metadata about it is being transferred to a set of Lambda functions whose job it is to take that chunk, transcode it into a bunch of different formats, take a thumbnail, do some analytics against that chunk, all of those things, and as soon as the transcoding activities are done, bundle them together, place them in a separate S3 bucket where the end user streaming clients are able to access them from in near real time. So an entire end-to-end video transcoding in real-time processing pipeline, fully implemented through serverless technologies, not a single server that they need to manage for this application. Okay. So you may be thinking, that's great. I kind of get the idea of, event-driven architectures now. There's these events happening, and it's pretty, asynchronous and on-demand when things need to happen. But your team may be set up with service-oriented architectures in mind already. Those are the skill sets your team has. Those are the architectures your review boards are familiar with. It may be a pretty far stretch for you to be able to start really changing and revolutionizing the way you're designing application architecture. So the good news is service-oriented architectures still work with AWS Lambda, and the service that enables that is Amazon API Gateway. Amazon API Gateway is a fully managed service offered by AWS to allow you to create an internet-facing API, configure that API with the URL and parameters that API requires, publish and deploy it, a lot of different lifecycle capabilities around creating different stages of an API, different parameters and variables that live within those stages, the ability to monitor your API, and add authorization to your API as well. And one of the biggest benefits of Amazon API Gateway is it gives you the ability to wrap a very common typical HTTPS API in front of an AWS Lambda function so that folks developing front-end components of your application are able to directly invoke and integrate with those Lambda functions you've written through a very common mechanism, an Internet API. So what I'm going to do now is I'm going to give a brief demo where I'm going to build a very basic serverless website using this model where we've got some static content hosted in Amazon S3, an HTML page and some JavaScript that's going to interact with the dynamic components through Amazon API Gateway, and each one of those APIs will integrate with an AWS Lambda function. And the Lambda functions will house all of the business logic required to implement this application. So if I just share my screen now, I'll show you what we got. Okay, so here's our application. And keep in mind this is primarily for educational purposes, so this is a very bare bones application, very stripped down, only containing the level of detail that I think is important to demonstrate with. So this is our serverless shopping list. It's going to give users the ability to enter a specific ID, a unique identifier for their shopping list, and retrieve items within that shopping list, and then come to the same shopping list and add new items to the shopping list as well. So if we take a look under the covers at the way that this is implemented, just so you see there's no smoke and mirrors, it's a very simple HTML page, just the text that you've seen, a couple buttons, and then very simple JavaScript that's going to be reaching out to a specific Amazon API Gateway API. And through HTTP posts, HTTP gets, I'm invoking two different methods that I have exposed on that API. So nothing very unique here, very common Angular interaction with a backend API. Nothing that's unique to Amazon API Gateway here other than the URL where it's deployed. Okay. So if I'm going to show you kind of how the backend, we'll work from back to front and show you the way that the backend is implemented first. So the place where those shopping lists are stored is in DynamoDB. So if I go to the DynamoDB console, just to show you again how things are implemented, I have a shopping lists table here. And there's a single item stored in it today, just one. It has a single item in it called apples. So if I go back to the shopping list and retrieve my shopping list, you'll see that I have that single item in it called apples. There's nothing else for me to get. If I try to retrieve a separate shopping list and retrieve it, I'll get a response that's containing nothing. So that's all we have. And what I'm going to walk you through now is the ability to add items to the shopping list through a new Lambda function because I only have the ability, I only have implemented right now the ability to retrieve a shopping list. So let's do that, kind of moving from the code to the implementation. We're going to think about development first. So the way that we're going to do that is, the way I've implemented is with Java. And I'm just going to walk you through the very small amount of code required to create this application and deploy it with Lambda. So the POJO I'm working with here, my data model, first and foremost, is a shopping list. It's very simple. I have a single string. If I zoom in here, give people a little better view. I have a single string that represents the unique identifier of a list ID, and then a list of strings that are all the items in my shopping list. And again, it's pure Java, whatever you'd want that data model to be. As long as it's serializable, you'll be able to model it however you'd like. Next, I'm using the typical standard AWS SDK to interact with that DynamoDB table. I have a single method that's relevant here implemented called addItem. That addItem method retrieves that unique list ID, a string that represents the item to be added, and I'm passing around the logger object if I wanted to make any log statements to be sent to CloudWatch logs. And then within the method, all I'm doing is retrieving a shopping list from another method that retrieves any existing shopping lists with that list ID, and then taking the item, adding it to the list of items within that shopping list, and then calling put item on the DynamoDB table to reinsert that shopping list with the new item inserted to it, appended to it back in DynamoDB. And again, using the pure AWS SDK to interact with DynamoDB. There's no other code hidden behind the scenes here. This is all the code that you'd need to write in order to interact with DynamoDB in a similar way. So that's all the business logic to take an item that's been inserted and write it to DynamoDB. Now, here's the Lambda relevant portion of my code where my handler exists. So this is the place where when the new Lambda function that I create is invoked, this is the place where execution will begin. And my handler method in this case, and you'll see me configure it in a bit once I set it up, it's called addItem. And all addItem is going to accept is this specific inner class called an addItem request that contains the list ID of the ID we're interacting with and the item that's to be added. Lambda will take care of, once an object meeting that object model here is sent into my Lambda function, it will deserialize the input, allow me to interact with it just from a Java object perspective, and then I'm going to, from within this method, call that same addItem method I showed on the back end. So if I zoom in just a little bit in case it's tough to see, this is my handler, and all I'm going to do is take the input request object and call the same addItem method I showed a second ago with the particular list ID and the item string that represents the item that's to be added to the list. And that's all the code I need to write. I don't need to write any code relevant to exposing an API, to wrapping this with security through IAM. I just need to write the business logic, a couple classes that are 50 lines or less each to give me the ability to write a really scalable internet-facing application that can be deployed in just a couple minutes. So that's all the code. So let's show you how to deploy it. I have done a little bit of pre-baking, so if we go to the Lambda console, I have the one Lambda function that exists already that you saw, my ability to retrieve a shopping list. So if I prefix everything with webinar, you can see that I've got one function that exists right now. I'm going to create a second one to give us the ability to add an item to the shopping list. So I'm going to create a Lambda function. I'm going to, one thing I'll briefly mention, so the blueprints listed here, which I'm going to skip for the purposes of the demo, exists here to give you a lot of examples and pre-written code in our interpreted languages. If you have a use case in mind, there's a good chance there's some sample code that exists within the console here that can give you a good baseline to get started with. If you wanted to write an S3 get object Lambda function in Python, you can choose one of these blueprints or one of the dozens of others to give you example code to do the task you might be thinking of. But in this case, I'm going to skip. And on this screen, you'd similarly be able to configure triggers or event sources for your Lambda functions. But also for this demo, I've got no need to do that because I'm going to set up an API that's going to invoke my function from the API side. So I don't need to configure the event source from within Lambda. And I get to this screen to give me the ability to configure my new function. So I'm going to create a new function called webinar add item. Again, my function is written in Java. And I've got two options to upload my code through the console. I can either directly upload a built zip or jar of my Java code, or I can provide the location within Amazon S3. So either one of these will give you the ability to get your code into the Lambda function. And I've already pre-built the code. I promise it's the same code that I showed you. And I've located it with, I've uploaded it to this location in S3. I'll provide that URL here. And then here is where you'll specify which method in my Java code is going to represent the handler. So if you're using one of the other languages, you'll have a similar type of idea. There's a notation that's well documented about how to point Lambda, the Lambda service, at your handler function. But this is where we list it. So in the nature of live demos, I've got that pre-written here. So it's just the Java package, the Java class, and then the method name that we'll be invoking. I'll paste that here. I'm going to choose an existing IAM role to wrap my code, and I've also pre-written that. But again, these are just IAM roles like any other. And then if I needed to, I have the ability here to increase the timeout available to my Lambda function. Be aware that today Lambda functions are only able to process for up to 5 minutes. And I don't need to increase the memory of my function. I don't need to deploy it in a VPC. So everything else looks good to me. Let's go ahead and create our function. So that's it. We've got our function created. Now the console does give me a couple other capabilities around testing the code. So now that we've got it created, let's pass in a test JSON event to add bananas to our shopping list. Now if we execute. And one thing to keep in mind, which this is a good time to mention it, if you're having a Lambda function that is running, it needs to be provisioned within that runtime environment by the service. And if it doesn't have any functions provisioned at one point, then you need to scale up and have those have your function be executed. There's a chance, especially with Java, that if you don't have a function already existing in the environment, that we'll need to provision one. And for Java, that means starting a JVM, and that can take a number of seconds. So that first execution time may come with it a performance hit. So there's a lot of strategies that you can do some searches for on how to prevent or sustain better performance with that first execution penalty. But once that function container is placed and you're already up and running, you won't have to worry about it. So if we test it again, you'll see that we've got null returning. We're just adding an item to a shopping list. I'm not returning any object here, but you've got full ability to do that if you wanted to. So if we go to our DynamoDB table again and take a quick look, back to the same table, we should see a couple bananas added to the shopping list now. Okay, great. So I clicked the button twice. We added 2 bananas to the shopping list. Great. It looks like my Lambda function code is working. We're adding items to the DynamoDB table. Now we just need to wrap an API around it. So let's visit Amazon API Gateway. And I have the API pre-built already for the get shopping list, but I'm going to show you how to add a new resource and a new method to add an item to that shopping list. So what we're going to do is we're going to create a new resource, a new sub-resource under list ID. So this is what my API looks like right now. I promise it's not too far down the road from initial creation time. There's only a couple clicks that I had to do to get that first resource created. But for this case, we're going to create a new sub-resource called items under a particular list ID. Standard RESTful patterns you might be familiar with already. I'm going to create a new method to allow somebody to use an HTTP post to create a new item and add it to a shopping list. So once that's created, I'll be prompted with what I want to integrate with on the back end. And for this demo, we're obviously integrating with AWS Lambda in the East region. I'll select the add item function I just created. Click OK. And now, because I'm integrating with Lambda and the API that Lambda provides has a particular object request notation where everything is an HTTP post and everything that's sent as the event is included as part of the HTTP body. Because I have a particular list ID represented as a path parameter, I'm going to use what's called an API Gateway Mapping Template to pull that list ID path parameter and include it in the HTTP post body that's being sent to my Lambda function backend. So I'm going to go to Integration Requests, Body Mapping Templates, and I'm going to create a new template for the application JSON content type. And I'm going to use the mapping template I've got pre-baked here. And all it is the VTL notation that API Gateway provides a number of different ways to get at dynamic parameters that are included in your API request. So in this case, I'm looking at the input variable of this particular request, and I'm extracting the list ID from those parameters, which represents this path parameter, list ID. And then for the item that's being sent back to my Lambda function, I'm looking at the input again, the JSON post body that was sent, and I'm looking for the variable item, the object item within that JSON object that was passed in. So I'm going to save this mapping template. Okay. And now all we need to do, because we're working with a front-end JavaScript app in the browser, we need to enable what's called CORS, cross-origin resource sharing, on this resource, so that my front-end browser gives permission so that the S3 deployed website can integrate with my back-end API. So nothing unique here to AWS. This is standard web development JavaScript situation. So good news is that it's a one-click configuration with Amazon API Gateway. I'm going to one-click enable it. You'll see that the options method has become available here. And I'm ready to deploy. So I'm going to redeploy my API to the same API stage that my existing get shopping list was located at. Click deploy. And I've got my new Lambda function, hopefully, is now available via the API that I just created. So if we go back to my shopping list and retrieve the shopping list again, you can see the bananas there, and now I should be able to add new items to it. And you can see it being populated here. So steaks there. Let's do Andrew's my new list ID, and we're going to add milk to it. We've got a new list there. And if I leave the page and come back to it, everything is still persisted in DynamoDB. You can see that the full app is working end-to-end, and you have the ability to fully and scalably interact with DynamoDB, write whatever business logic you require to in the middle, and all with no servers that you have to manage, fully managed by AWS Lambda. So great. So let's jump back into the slide deck. I just stopped sharing here. Okay. Cool. So we built a fully functional public-facing website no servers to manage at all of the static content in S3, all of the dynamic content implemented in Lambda accessed through Amazon API Gateway. And remember, with all those other serverless options we provide, there's a lot more cool functionality you could build just writing that business logic in Lambda, interacting with a number of other services. So next, a couple patterns that have become really popular. Microservices, obviously, we're talking about today. You can kind of consider a microservice in a typical environment to be just a paired Amazon API Gateway and Lambda function, and your persistence living in DynamoDB. Also popular are mobile backends, where you have all the best practices associated with native mobile app development, integrating with a backend API Gateway API, leveraging some of our mobile-centric service like user identity and profile management through Cognito, push notifications and SMS messaging through SNS. A real-time analytics engine where at scale all of your data is ingested inside of our Kinesis service at any scale required, and then have those records be processed by Lambda functions. So regardless of what that scale is occurring at, having your Lambda functions do whatever processing is required on that data as it comes in before it's persisted in one of our backend persistent storage options like DynamoDB. So a couple best practices to finish with, and these slides will be available to everybody, so don't worry, I'm not going to touch on every single one of these. They'll be written out and available to everybody. So first and foremost is limiting your function size. So don't let the function code you upload to AWS Lambda be the new monolith within your environment. For a couple reasons. One, just from a development sanity perspective, you don't want another monolith that has to be co-managed with teams that are codependent on it, but also the size of your function code impacts the start time for a Lambda function to be placed within the runtime environment. So the smaller your function is able to be, the quicker it will start, and the more decoupled your development processes can be. Number 2 on the right here, function aliases, is something I didn't get to touch on today, but take a look at those. It's a great way to decouple which version of your Lambda functions a client is interacting with, and it'll give you the ability to do a lot of testing and regression testing after a new version is uploaded, but before your clients integrate with that code in a production scenario. So take a look at Lambda function aliases. Okay. The last one, the best practices for API Gateway that I'll mention is another that I didn't have a chance to talk about today is mock integration. So Amazon API Gateway, if you're going to have all this speed from a development perspective on the back end, you might want to give your front-end developers something to interact with sooner in the process. So Amazon API Gateway lets you create dummy stub responses through mock integrations, where you can create some static JSON that represents what your final object would look like and a real HTTP endpoint for your front-end developers to integrate with, all while you're still implementing your back-end service logic. So take a look at mock integrations to help speed up the front-end development in parallel as well. The next one is Cognito. I'll mention it's a really powerful authorization model. The integration of Amazon API Gateway and Lambda for your compute, and using Cognito for your identity management and its integration with Amazon Identity and Access Management roles gives you this really powerful fine-grained authorization at a user level, where you can have things like DynamoDB records that are limited in access to very specific users, or S3 bucket prefixes that are limited to very specific users based on their Cognito ID. So take a look at how Cognito integrates with this whole story, and you'll be pretty excited about it, I think, too. Some additional best practices is, one, you've got a lot of different things you can name within this architecture model. You've got your function names, you've got your IAM roles, you've got your APIs. Be very strategic in creating consumable names that are following conventions to let you report on them and create a lot of automation operationally around those names. Next is the last one I'll leave you with is the IAM roles. Decouple your security wherever possible and externalize any authorization you can to IAM. The ability to have your developers who in your environment may not be the party who's responsible for IAM roles and managing credentials, giving them the ability to write completely security agnostic code, while the folks on your team that do manage creation of roles and what those roles have permission to do can define the security posture of the application external from the code. Credentials don't have to live in source code repositories. They don't have to You don't have to write any code to ingest them or decrypt them, things like that. Security is much, much simplified when you can just wrap these Lambda functions in an IAM role. And the last one, as you're getting started, if you're thinking about a use case where you're going to be adopting at pretty large scale, and you think you know what that scale is, be aware that, like a lot of other services, there are service limits in place with Lambda and API Gateway. So please engage with AWS support if you suspect that your use case is being throttled by one of those service limits, or you know about a scaling event that's on the horizon, just to make sure that we have a chance to talk with you about if any of those service limits need to be raised. So the last thing I'm going to leave you with before we get to some Q&A is just a call to action. You saw how easy it is and how little code you need to write to build a fully scalable and managed application with this model. I'm going to ask that those of you who feel excited about the productivity and the speed that you'll get, just go build something. Think about a way, a cool use case that you can build with these three components: Amazon API Gateway, Lambda, and DynamoDB, and get off and running. Get your hands dirty with the technology. I think you'll be really excited with the things you're able to do using these services. All right, great. So let's jump into Q&A. All right, let's jump into some Q&A. So we have one question about Suresh is asking, as a DBA, how much can they leverage the Lambda service to replace crons or other scheduled jobs? Great question. Specifically for replacing crons, there is the ability to, one of the event sources I didn't touch on is the idea of a scheduled Lambda function. So you can create a particular schedule very similar to cron where your Lambda function will be executed on that schedule. You also have the ability to integrate with what's called CloudWatch events, part of the CloudWatch event service, where if a particular event that happens within your environment takes place, you can trigger a Lambda function from it. And one of those events can be based on a time schedule, like every minute, every 5 minutes. So if you want to know some of the best practices to keep those function containers alive, like I mentioned before, integrating with a scheduled Lambda function every 5 minutes, or a CloudWatch event source every minute is a great way to send a heartbeat pulse to that Lambda function to keep the container warm, keep it alive, so that you don't have a real end user who's got to pay the first invocation penalty of a JVM starting or something like that. Okay, so a question from Paulo. Are there any best practices to use Lambda in a common development workflow with multiple environment and development stages? So yes, there certainly are. I actually gave a webinar a couple months ago that's kind of a next step to this one called Continuous Delivery to AWS Lambda. It's available on YouTube. I encourage folks to take a look at that. But the main idea here is through understanding of how you want to leverage Lambda aliases. So it's through those Lambda aliases that you're able to specifically target versions of your functions and invoke those versions while the versioning of the function continues to iterate into the future. So you could have a couple different strategies here depending on what model works best for your development. You could have a single Lambda function that has an alias that represents QA and another alias that represents development and another alias that represents production. And depending on which lifecycle you're in, the client side of that API and the client side of that Lambda function will invoke that particular alias of that Lambda function in order to call the correct version that's been approved and blessed to be at that point in development. The other option is to have separate Lambda functions that represent different stages. So you could use naming conventions to say you've got function1-dev or function1-QA, or function1-prod, and then your continuous delivery processes would manage taking the code that's been deployed and moving it between those different functions. And again, I encourage you to take a look at that other webinar that's available on YouTube, Continuous Delivery to AWS Lambda, to learn more about some of those strategies. Next question. Can you host an entire app web server API on Lambda, or is it just reacting to events as they happen? So it is event-driven, but you'll be hosting kind of the logic tier or processing compute capabilities within AWS Lambda. The way that you'll invoke it is through those event sources and the handler function. So it's not the same concept as working with server-based infrastructure where you've got this always-on piece of infrastructure, an operating system, where you'll be installing software that's exposing ports and all of those sorts of things. This is truly, you're going to upload your function to contain only what your business logic needs to be, and then invoking that business logic through the different event sources that we make available. Now, it's not to say that you can't build an entire application that's not built fully on Lambda, but the code that you write and the way with which you invoke and integrate those pieces of code will be through those event sources and the Lambda API. A different model than if you're deploying a server-based application. Okay, next question. Is AWS Lambda something similar to what exception handling is in Java, event, trigger, and handle? No. So it's similar words, but definitely different different implementations, different definitions. So the way with which we're using the definition here is the handler is the place within your function code that is specifically handling execution, where execution begins. And if you're speaking about kind of how are exceptions handled within AWS Lambda, you're using the true Java programming language or the other languages available with Lambda today. So if you want to throw exceptions and have exceptions be handled within your code, you certainly have that capability still. But if the question's about the nomenclature of Lambda correlating to exception handling, two separate things, just overlapping terminology. Another question. Question is, does a serverless architecture intrinsically depend on client-side JavaScript? So can it be done using JavaScript-free fallbacks for users without access to JavaScript? Good question from Joseph. So my demo was using front-end JavaScript and Angular just as a mechanism for calling an API gateway API. So depending on how you want to expose and integrate with your Lambda functions through those different event sources, you've got a plethora of different options. So any other frameworks or libraries or languages or capabilities that you'd like to use to integrate with an API, those will still be able to integrate with those API gateway APIs, and then on the back end trigger the Lambda function to be executed. And if you're building something that's using a different integration model than just through APIs, if you'd like to, kind of like the customers, the Play on Sports example, where there's no APIs or JavaScript they're interacting with there. They're uploading source files and source videos to Amazon S3, which are triggering the Lambda functions to execute. So take a look at all the different event sources that are available to trigger and invoke your Lambda functions, and that'll give you a good idea of the different integration models and different application front ends that the clients you can kind of consider that'll be able to act as an entry point to your Lambda code. Next question from Swati is, can you chain the Lambda function? So great question, and the answer is yes. So again, this is application logic that is fully yours to write. And there's a couple different ways in which you can chain Lambda functions. So first is, because it's your business logic, you can have your code directly reach out to another Lambda function or create an event in one of those event sources that would in turn trigger another Lambda function to run. So whatever that decoupled workflow or application architecture would need to be, fully up to you how the different Lambda functions will get invoked and integrated within the environment. And the other option, if you take a look at our simple workflow service, there's a new option to have, if you're familiar with it, there's another option now to have your deciders and your activities be represented by Lambda functions as well. So if you have a use case that's workflow or chain based, take a look at the simple workflow service and how it integrates with Lambda today. Just time for one last question. So we've got a question from Robert. Oftentimes there's a web service request, you need to interact with a database, you need to set up and tear down a connection, which can take a while. Using connection pools is a great way. How does Lambda deal with this? So really great question. And there's a couple different options you have with working with relational databases today if connection pools are important to your use case. So keep in mind that these are fully stateless containers. You need to write your code as if it were stateless. And so the idea of connection pools isn't something that is natively a supported concept with Lambda. So the way that you'll be able to kind of get the same capability is integrating with one of our event sources that allows you to create throttling bottlenecks that will define the amount of throughput your Lambda functions will receive. So look at something like Kinesis or Amazon API Gateway, which can do throttling. And if you're able to do throttling from that perspective and ensure you've got good knowledge of how much throughput is needed and how many containers and functions will be running in parallel, you can have a lot more confidence that that same number of containers will continuously be up and running and reuse their connections if they're still open. But keeping all that in mind, you still need to be able to implement your code with statelessness in mind. And if new function code is uploaded to Lambda, new containers are provisioned. So it's definitely a good question. There's a lot of thought that needs to be put into how your database is interacted with and how it'll affect your application. But good question. And I think that's all the time we have for today. So thank you everyone for taking the time and helping, dealing with a couple technical glitches we hit there. If you would, please remember to fill out all of the poll questions on the left there, especially if you are very satisfied. And thank you again for joining, and enjoy the rest of your day. Thank you.